Hello everybody, welcome to this video lesson. In this video lesson, we would like to start talking about a new chapter, wave optics or physical optics. In the previous video lessons, lots of video lessons, we have been talking about ray optics. Now we are going to talk about wave optics. To remind you back, light exhibits a wide varieties of properties which can be broadly kept in three different categories. We can say reflection, refraction, dispersion, deviation, and so on. Basic level of properties. This can be one set of the properties of the light. It can also exhibit properties like interference, diffraction, polarization. This could be called under set 2. Light also exhibits a third set of the properties like photoelectric effect, Raman effect, Stark effect, Zeeman effect, and so on. These are the modern days effects. These three are three different categories of the properties of the light. Earlier, we have explained all these first set of the properties in the chapter ray optics. We will be explaining the second set of the properties in the present chapter physical optics. Whereas these properties are dealt in modern physics. To explain all these properties of the light, so we depend on different theories like we have explained in the previous video lessons of ray optics, like Newton's corpuscular theory. It is further improved by Huygens wave theory. It is further improved by Maxwell's electromagnetic theory. Finally, Planck's quantum theory. But it is understood, if you remember back, that no single theory can explain all the properties of the light. Therefore, it is assumed that light is going to have a dual nature. So people say that light travels like a wave, and when it is interacting, it interacts like a particle. So this is called something like dual nature of the light. When it is traveling like a wave, then depending on with what kind of the objects it is interacting. Say for example, if light deals with objects while it is traveling that are much bigger than the wavelength of its light, much bigger than wavelength, that is visible wavelength, with GR wavelength, that is around something like 4000 angstrom to 8000 angstrom approximately, much bigger than the wavelength of the light if the size of the object is. Being the objects are very big in size with respect to that objects, the wave doesn't appear like a wave, rather a wave appears like a straight line. Wave appears like a straight line. Taking that as a basis, we can explain all this first set of the properties. That's how we have explained, say, ray optics. Suppose if we are handling the objects, if object size is comparable with wavelength of the light, then the wavelength cannot be ignored. The light appears like a wave, and we study it under wave optics or physical optics. In this present chapter, physical optics, we are going to study about these three properties like interference, diffraction, and polarization. Of course, when it is interacting with somebody, then we use Planck's quantum concept. We talk about this modern physics in a later stage. Now we are not going to worry about it. So we can simply put a condition like if b square is much greater than that of L lambda, where b is the size of the object that we are handling, L is the distance between the object and the screen, and lambda is the wavelength of the light that we are handling, we study it under ray optics. If b square is approximately equal to L lambda, we study it under wave optics. This is the present condition that we are going to use in all our further topics, right? Further, we can say when we are handling these conditions like wave optics, we mostly depends on Huygens wave theory. We mostly depend on Huygens wave theory, which is explained in the previous ray optics video lessons. Please go through if you are not aware of some of its basics. That Huygens, basing on Huygens wave theory, we can explain both interference as well as diffraction. But anyway, to explain polarization, Huygens wave theory is not sufficient. We use Maxwell's electromagnetic wave theory. So we are going to use Huygens wave theory to explain interference and diffraction, and we are going to use Maxwell's electromagnetic theory in the coming video lessons to explain polarization. Stay tuned, coming back for more and more video lessons on wave optics. Thank you for watching. Thank you.